Okay, so here we're going to look at area of compound shapes. And the first thing we need to do is be able to split up our shape into sensible shapes that we can use a formula for. So this first one, the most sensible way to do this, especially if you know the formulas or had the formulas in front of you, okay, is to split it into a trapezium and a rectangle. Now the trapezium is the shape here with the pair of parallel sides. Okay, that's all it needs to have about it. Pair of parallel sides. Got a few here for you to just look at quickly. Down here. So if we look at these trapeziums here, these trapeziums, these top three, you've got a pair of parallel sides there. Okay, the other two can be anything else, just four-sided shape. This pair of parallel sides actually goes vertically, and this pair of parallel sides is quite tricky to spot unless you're told that they're parallel. These two here make it look a bit strange. You also need to find your height. Now in this first one, this height is marked on here and it's at right angles to the base, or right angles to the parallel sides. Here is your height. Okay, so the height is that 7 across the bottom. Okay, so this is the height, although it's sitting down. If you turned your page around, that would be standing up like a height would normally be shown. And here, the height, oh, it's actually had to be brought out to the side, but it's still at right angles to that parallel side at the top and the parallel side at the bottom. It's at right angles to the two parallel sides. Not to be mistaken with a parallelogram. Okay, this is a parallelogram. Parallelogram. Okay, this is a parallelogram. Now that has two pairs of parallel sides. The top side must be the same length and at the same angle as the bottom, and the two side pieces must be the same direction, exactly the same angle as each other and the same length. So parallelogram, not to be mistaken for these trapeziums, which are four-sided shapes. Okay, and sometimes the lines are a little bit off and you could almost mistake it for parallelogram, but parallelogram most definitely two separate pairs of parallel sides, so they're the equal length and they're exactly the same angle to each other. Just a quick recap on that. Okay, so back to our shape. So the trapezium here, we're going to use trapezium area rule. So area of trapezium. Now you will have a formula sheet for this. Okay, but just worth practicing it is your A and your B, and in this case your A and your B are your parallel sides. You have your A plus your B and you halve it, which means you're finding the average of your parallel sides. So you're taking a bit off one and adding a bit onto the other to make them same length, and then you're multiplying by your height. Now your height in any shape, mathematical shape, is always at right angles to the base. You can see it's at right angles to the base here, times your height. So you need to label the actual amounts. So here we've got 2, here we've got 2, 4, 6, so 6 squares along, and this height here is also 2 centimeters. Now in this question, in the original question, it told you that 1 square was 1 centimeter long. Okay, so we're just using this scale they told us in the original question. So we've got substituting in, you won't get anything for pulling that formula out, you have to use it. So it's your A length plus your B length, and then you're going to halve it. I'm going to multiply it by the height, and this happens to be 2 as well. There's just far too many 2's in this question. So it's our parallels added together, halved, and times 2. So we've got 2, 6, 8. And I'm writing every single bit out in case I go wrong in my head or I forget something in my head. You can never check, the marker can never check your head for working out. So 4 times 2. Okay, so final answer for that trapezium is 8, and it's centimeters squared because we're doing the area. Okay, it's about coverage. And this rectangle here then, We've got 2, our width, and we've got 6 along the bottom. 2, 4, 6. So our rectangle, or if we had a square, it would be similar. And actually a parallelogram is actually the same formula as a rectangle. Okay, it's just the length times the width. But actually, in a parallelogram, you'd have your base times your perpendicular height. It's like a squashed rectangle. Just show you that quickly, actually, on this other one down here. It's parallelogram. So an area of a parallelogram, would be the perpendicular height. Always the perpendicular, never that slopey side, okay? It's the height here. So the area of parallelogram would be the height and your base. Okay, height times base equals the area of parallelogram. If you look at that further, you can take the triangle off this end and put it on that, and you've got a rectangle. Okay, so just to recap that very quickly. But we're dealing with trapezium and a rectangle. So here we've got the length is going to be 2 times 6, which equals 12. And that's, again, put the units of measure on at the end. Don't forget that unit of measure. It's really important. It could lose you a mark. Now, the total area of the whole thing, don't forget to add them together at the end of the whole shape, is going to be 8 centimetres squared plus 12 centimetres squared equals 20 centimetres squared. Do not forget to add them together at the end for your final area. If you don't do that, you don't get the final mark. Okay, so I've just drawn 2 more copies of this at the bottom, because actually you've got 2 other ways of doing this. If you don't understand the trapezium rule, even if you're given it, you can actually split this shape into another way. Now you could actually still split that rectangle. That rectangle is really quite obvious. Got your rectangle here, okay. And then you could also split this into, if you prefer, a triangle. You've got a triangle here, and you've got an identical triangle. As it happens, they might not always be identical. The trapeziums could be lopsided. But you have got two identical triangles here, congruent triangles, no less, in exactly the same. And in the middle here, you've got a square, so you could split it that way and do your 2 triangles. Remember your triangle rule, which would be, okay, triangle rule is going to be base times height. Okay, it's always perpendicular height, never that slopey side, half. Okay, that could be one way of doing it here with your square and your rectangle. Add them all together. The other way, absolute safety blankets, this is a last resort, is to count your full squares. 1, 2, 3, 4, 5, 6. And we know there's 12 here, so we've got these ones here as well. Or we could do the rectangle. So you've got 12, 13, 14, 15, 16, 17. You've got 18 full squares. Okay. Now you can only do this method if you have not got a circle or part of a circle, because then it doesn't get accurate enough. Now the generally accepted rule is with any the polygon 2D shape without those curved edges, every pair of part squares, no matter if they're exactly half or not, you just pair them up, count all your total part squares, they will match up and make a whole square. So we've got 4 part squares. In this case, they are actually halves. 4 part squares. And they would actually equal 2 whole squares. And you can see it here, but it's just a real safety blanket. So if you can do the formula, that's the best way of doing it, is the formula, or this triangle formula. This is a safety blanket. So now we're going to add up our whole squares here and our whole squares here, and we do indeed get 20 whole squares, and because they're centimetres, they're 20 centimetres squared. So we get the same answer, but a bit of a safety blanket approach. Okay, this formula method is the best approach, the most mathsy. It's showing you've understood the formula, showing you've substituted the formula. If you get that final answer of 20 and didn't use the formula, you may lose marks along the way for not using the sort of formula method, but you may get the marks at the end for the full answer. If you get the wrong answer at the end here using this method, you will unlikely get marks for any working out because you've not used a sort of a standard method. You're using a safety blanket, but it's just a good safety blanket for a check maybe as well. Go for the formula if you possibly can. This one here. So now I'm going to split this. I have got a couple of ways of doing this, hence my other shape down here. First of all, I've got it as part of a circle, so I'm going to actually mark that off as a semicircle. Now they should tell you if you've got a half a semicircle or quarter of a circle, so you know that it's exact and it's not sort of, you know, not guessing. So here is my semicircle, and this diameter is 3. Okay, so the diameter of my semicircle is 3 centimeters, which must mean that my radius is half of that, which is 1.5. And you can actually see that on this diagram too, actually. If you go from the center here and you go center of the circle, what would have been the center of the circle, all the way to the outside, that is your radius there, which is 1.5 squares. Okay, but it gives you away with the diameter there across the top there. Right, so now the next part of this, I'm going to use trapezium because I've got a pair of parallel sides here, like this. I've got a height here of 3, so this is my height, as well as being the diameter of the circle, it's the height of my trapezium. And I've got an A and a B. Okay, this length here can be ignored for this question. So an A and a B, the A is 4, the B is 2, 4, 6. The diameter and the height is 3, the radius 1.5. So my trapezium is going to be over here. A plus B over 2 times 4. So we've got, so I should put the height there, right? Just confuse you, just to make sure you got the formula. Times the height. So we've got, substituting in, 4 plus 6. Divide by 2 times by that height, which is not 4 even, it's 3. See, I'm getting confused with my numbers here, so go check the diagram. That's why it's good to always write on the diagram, so you've got to refer back to. So that's 10, and I'm writing every part out. And that then gives me 5 times 3, because 10 over 2 is just 10 divided by 2. So the final answer for the trapezium part is 15 centimeters squared. Now don't get ahead of yourself and think you've finished. That's just the trapezium. So I'm going to put that in here, 15 cm, and it's squared because it's area. Now the circle then. That's the circle. So we want to have the area of our circle. Area of the circle . Okay. Now the formula for this is pi r squared. Be very careful, you only square your r. So let's have pi. And if you don't have a pi, can't find your pi button on your calculator, just always ask the person who's running the assessment for you. They should be able to show you where the pi button is. And then pi, if you can't do that, you can always do r times r. So that's, again, a safety blanket. So you don't square the wrong thing. You've put your r in twice, it's timed them together. So let's now substitute some values in there. We've got our pi times 1.5. You can use the squared on your calculator, or you can do, again, the safety blanket, so you don't go squaring the whole thing by mistake. 1.5, but type it in very carefully, times 1.5. Okay. Let's just put that into our calculator. Okay, so we've got, oops, just lost my screen. Right, so we've got, now this is where you should always put a few decimal places in. We've got 7.0 6.858. Okay, and that's cm squared because it is area. Now, this where don't get ahead of yourself again. You're not finished because you've only got half a circle. You've got a semicircle here. So you have found the area of a whole circle. So be very careful. Now, you now need to make sure you divide that whole circle area by 2 to get the semicircle. Same if you'd had a quarter, you'd divide it by 4, an eighth divided by 8. So we're going to divide that by 2 to get our semicircle, and we get 3.534. Okay, centimeters squared. Now, again, this question is not finished. We need to make sure we've got the area of the whole shape. So that would be 15 centimeters squared plus the 3.534. Oops, what's happening to my pen here? It's going to be weird. That should be a 3. Okay, and actually the question, if you saw the whole question, it actually had asking for 1 decimal place. Sorry, I'm just struggling with my pen here today. Right, 18.534 and rounded to 1 decimal place will be 18.5 centimeters squared. Okay, so final answer there. Make sure you always make it clear what your final answer is. Okay, now the reason I've put this other shape down here in the corner is because there is another way of splitting this up. If you can use your trapezium rule, it's going to be perhaps quicker to do this, to do the trapezium rule. But here we've got a triangle, so if you use your triangle rule, and you've got a semicircle on the end here, and the rectangle in the middle. So you might find it easier, prefer to do that. So we've got semicircle on the end, we've got the rectangle in the middle, and you could have that triangle on the front there. So you could do it in 3 parts like that, but just be careful, you've got half a circle, so you must make sure you halve your circle area at the end. Okay, so split it up, get the formula written down, substitute the numbers in and calculate it carefully. Okay, right, the last one here, this is a bit of a strange one. You've got to still find the area of the shaded shape. Now you can't possibly find the area of that shaded shape straight off. You have to find the whole thing, the whole trapezium, and then cut out the circle at the end. If it's a cutout, it means you're going to take away at the end. So let's just mark off our trapezium. So trapezium is here. There's our pair of parallel sides. It could also have been, of course, drawn this way around. There's our pair of parallel sides. And we need to put in the height. So the height we put anywhere between the 2 parallel sides. Got parallel at right angles to the parallel sides there. So right angles to the base. And actually in this case, because they're parallel, it's right angles to the top as well in a trapezium. Okay, so there's our height. There's our A and there's our B. The height could have been dropped in here. That's also the same height, top to bottom at right angles, exactly the same size. Okay, going there. Right. And then if you now deal with the trapezium first, so A plus B, we're going to find the average of those parallels. We're going to times it by the height. Okay, we're now going to substitute. So let's count up. We've got 2, 4, we've got 5 along the top there. We've got 2, 4, 6, 7 along there, and that height is 4. Oops. That height, is pen to stay still, doesn't want to behave today. Right, that height is 4. It's working in a minute. That height is 4. Okay, so let's substitute in. We've got 5, we've got 7. 5 plus 7, we're going to halve it. Then we're going to times it by our height of 4. So we've got 5 plus 7 is 12. We're going to halve it, times it by 4. So we've got 6 and times it by 4. I should have written 4 there, sorry, not H. Times it by 4. So we've got 24 centimetres, and that's squared because it's area. Don't forget your units on the end. Okay, really important. So now we're going to think about circles. That's the area of the whole trapezium. We're going to cut this circle out. So with our circle, we need to find out the radius. Now, if you look across here, the best way, this is going through the centre here. So this is our diameter. Okay, not so simple to see, but it is actually 3 whole squares and 2 halves. That is 4. Now you could see that also if you come down here, right through the centre, you can see, okay, top to bottom of the circle, it's also 4 through those middle of that square there. So your diameter is 4 centimetres. Therefore, your radius must be half of that, which is 2. It's a little trickier to see it on the diagram. 2 centimetres, you can just about see it. If you get the centre of the circle, top of the circle, and come down here, you can see your radius is 2 squares. So, area of your circle equals pi r squared, pi times r squared. So that equals, bit of substitution here, times 2 squared, or the safety blanket method, pi times the radius times the radius. Now, if you haven't got a pi button on your calculator, you should always use pi as an approximation, because you'll have a calculator for this, but so you should use a little bit of accuracy, 3.14. Okay, that's your approximation of pi if you don't have a pi button. Okay, so pi times 2 times 2, just plug that in the calculator, is going to be, let's write it here, 12.5664. That's not my whole calculator display, but I always put in a couple of places, a few decimal places extra, and then you can deal with the accuracy bit at the end. So that is your whole circle. Be careful here, you're not adding them this time. You want the shaded bit only, so you're having the trapezium, take away the circle. Okay, so let's just draw that on here. You're doing the trapezium in this case, and you're subtracting the circle. All right, so 24 centimetres squared, subtract 12.5664, and in your calculator you get 11.4336, and if that's to 1 decimal place, that would be 11.4 centimetres squared, don't forget on the end, and that's to 1 decimal place. Okay, that's your final answer for this question. It's a cut-out one. All right. The main thing then with these questions is to first make sure you get your shapes right, and that's dealt with here. The trapeziums have 1 pair of parallel sides, and they could have right angles. They don't always have right angles. It could be a bit weird like someone on the end. Okay, so pair of parallel sides. Your height could be over here, or your height could be fallen down on the bottom here. You can have a right angles in it. You might not have right angles in it. You may have what's called what we sort of an isosceles trapezium, where you've got the same length slopey bits here, and it's sort of you have some symmetry to it, but you could have a trapezium where it's not symmetrical, like this yellow one here. Okay, so it's your A and your B and your height. Do not mistake it with a parallelogram. Parallelograms have 2 pairs of parallel sides. They must be exactly the same length and at exactly the same angle. Okay. Okay, remember to split your circles. I've got circles, split it up and split your shape down like that. Okay, good luck.